Hi friends, welcome. My name's Caitlin and I'm going to be teaching you Math Saxon 7-6 today. This is going to be our very first lesson. It's from this book. It's the 4th edition. Grab a piece of paper. You're going to want a notebook for all of your notes. So things that I write down, you're going to want to write down as well so you can practice these. Okay, first here, these are all the examples from the book, but I want to go over them with you individually. First things first, the commutative property. Let's talk about this. The commutative property basically says, the commutative property of addition basically says that you can add in any order. That means that 3 plus 5, that's going to give me 8, and 5 plus 3 is also going to give me 8. So we can add in any order. That's going to be helpful for these next few lessons, so I want you to keep that in the back of your mind. All right, let's jump right in and go on to these examples. We're going to be adding these numbers right here. Now, I've set aside this paper to do the work. However, and you can do it totally on line paper like this. However, I find a lot of kids need help being organized. So I'm going to swap this out here and we're going to go through and do these problems sideways on a paper like this. So for example number 1, we have 345 plus 67, and you'll see that I'm lining up those place values and the lines by going up and down make that really easy. And this is helpful, especially when we're dealing with decimals. First things first, we're going to do 5 and 7. That's going to be 7, and then we've got 3 is 10, and 2 more, so that gives us 12. 4 and 6 is 10, plus 1 more gives us 11. Carry that 1, and 3 and 1 gives me 4, so your answer should be 412. All right, let's look at example number 2. This one says 125 plus $12.50, so plus $12. I probably should have put the dollar sign at the end. $12.50 plus $5. Now remember, in math, so it's plus $5 right here. In math, we have some things that are called invisible math, things that that we don't write, that we just assume you know. One of those is if there's no decimal shown, it's at the end. So for this $5 here, it's at the end. So we're going to say $5. And going forward, we'll disregard these dollar signs for right now until we get to our answer, because it can be a little confusing. Okay, so whenever we're adding and subtracting decimals, you have to line them up. Let's go ahead and bring this decimal down. And I have 5, and so 25 cents and 50 cents is going to give me 75 cents. Or you can just do 5 and then 2 and 5 would give us 7. 5, 6, 7, and 8. And then 1 and 0, 0. So it gives me $18.75. Okay, let's look at example number 3 here. This guy's going to be a subtraction problem. We're going to say 345 minus 67. All right, this is going to be a subtraction problem with borrowing. You'll see right away we can't do 5 minus 7 because you can't take 7 away from 5. So we need to borrow. So we're going to come over here. We're going to borrow, which makes this a 3, and we're going to add 10 to this, making it a 15. So 15 minus 7. 7 and 7 is 14. Plus 1 more, that gives me 8. Sorry about that, started coughing. All right, so then 3 minus 6, I can't do that, so I'm going to borrow by making this a 2. Add 10 to 3, which gives me 13. 13 minus 6. Well, 6 up to 10 is 4, and from 10 to 13, that's 3 more, so I have a total of 7. And then 2 minus 0, that's just 2. So your answer is 278. Excellent. Okay, for number 4, you'll notice in the book it says, Jim spent $1.25 for a hamburger. He paid for it with a $5 bill. Find out how much change he should get back by subtracting $1.25 from $5. Whoops, helps if I put that on the screen. Now, I'm going to show you 2 different ways of doing this. The first one is we want to know how much change he gets by subtracting this from this. And I'm not going to tilt my paper sideways for this one because I just want to show you. Remember, this has 2 digits behind the decimal, so my $5 has to have 2 digits behind the decimal. I'm going to take this guy away. 1.25. Okay, here's the old way of doing this. 0 minus 5 I can't do. I can't borrow from 0, so I got to go all the way over here and make this a 4. If I borrow from here and make that a 4, this becomes now a 10. Now I'm ready to borrow. Cancel this guy out and make it a 9 and make this a 10. 10 minus 5 is going to give me 5. 9 minus 2 is going to give me 7. 4 minus 1 is going to give me 3. So that's the old school way of doing that. There's another way, and this actually works a lot better as you get the hang of it. It can be really tricky at first. we want to go from $1.25 up to $5. Okay? $1.25 up to $5. Well, dealing with quarters is nice because that's super easy. From $1.25 up to $2, that's going to be 75 cents. From $1.25 to $2, that's 75 cents. From $2 to $5, that's going to be $3 whole dollars. So I have 75 cents and I have $3. That's $3.75. If that method did not make sense, don't sweat it. That will come as you start growing more in math. I like to show it both ways just so it makes sense for those who want to use it that way, but you can always do it this old school method too. Old school or, whatever. It's still totally valid. I don't even know if it's old school. All right, the next part we're going to talk about is our fact families. Now, fact families are super important for understanding how to manipulate addition, subtraction, multiplication, and division problems. We have 4 operations that we do: addition, subtraction, multiplication, and division. And so with those operations, we have these fact families. The first one we're given is this. We want to create a fact family for this. All right, well, here's what we do. You'll see that we're subtracting in this direction. When you are subtracting, you can flip these bottom 2. So now our new fact becomes 11 minus 5 is 6. When you're subtracting, you can flip these bottom 2, okay? Now, like I said, we're subtracting in this direction. We can add in this direction for both of those. And what I mean by that is 5 plus 6 gives me 11. And from here, 6 plus 5 gives me 11. 6 plus 5 gives me 11. So you'll see, when we're subtracting, we can flip the bottom 2. When we're adding, we can flip the top 2. This is going to be really important as this unit goes on. So keep that in mind. If you have any questions, let me know. All right, for these guys, practice problems. So here are the practice problems. They are, go ahead and pause the video, do them, come on back, and let's make sure you got them right. Okay, so here are the answers for the practice problems. Go ahead and pause the video, correct your work, and if you got them all right, great work. If you did not, let's do those together. So I'm going to go back to tilting my paper on the side because I think that will help. So for A, we've got 3,675, then 426, and 1,357. Okay, so on this guy, we've got 5 and 5 is 10 plus 1 more to make 6, right, is 11. 11 plus 7 is 18. Carry my 1. 7, 8, 9, 10. 10 plus 5 gives me 15. Carry my 1. 6 and 4 is 10. Plus 3 is 13. Plus 1 more is 14. 3 plus 1 gives me 5. So you should have 5,458. All right, for B, I just realized I didn't put the fact family answers there, so hopefully you guys are all sticking around. 6.25, $6.25, $8.23, and then $12. Now remember, if a decimal's not shown, it's at the end. So $12 like this, and I've got my decimals, and you can always put zeros after your decimal. It doesn't change anything. You can write $12 like this, or you can just write it like that without the zeros. Okay, so we are adding. Yes, we are adding these guys. 5, 6, 7, 8. 2 and 2 is 4. 8 and 2 is 10 plus 6 gives me 1. Sorry, let's try that again. 8 and 2 is 10 plus 6 gives me 16. Here's my 6, carry my 1. I get 2648. All right, let's look at C. Now C is a subtraction one. 5,374 minus 168. Okay. Now 4 minus 8 I can't do. I got to borrow, so I'm going to make this a 6 and make this a 14. 8 up to 14 is 2, or I'm sorry, 8 up to 10 is 2. From 10 to 14 is 4, so I have 2 and 4. That gives me 6. So 8 and 6 will give me 14. 6 minus 6 is 0. 3 minus 1 is 2, and then 5 minus 0 is 5. So you should have 5,206. All right, D says, this is another one where it's $5 minus 135. So $5 minus 135. All right, We could do all the borrowing, but I want to show you that trick one more time. Well, let's do it the old way first. So we can't borrow, so we got to go over here, make that 4 and this a 10. Now we're in a position ready to borrow. Borrow from here by making this a 9, make that a 10. That's 5. And then from 3 up to 9, we get 6. 4 minus 1 gives me 3, so $3.65. Let's talk about that though. $1.35, and I need to go up to $5 because I'm subtracting those. I want to find the difference. That's a key word. Difference means subtract in math. So from 135, well, from 135 to, let's say, 140, that's 5 cents, 0.05, not 0.5, 0.05. From 140 up to $2, that's 60 cents. From $2 up to $5, that's going to be $3. So when I add all this together, $3, 60 cents, and 5, I get $3.65. Okay, so let's talk about fact families now. These are the ones I didn't show the answers for. So the fact family that you want to do is, we want to do addition and subtraction. So for 6 and 8, I always think it's easiest to start with addition. So 6 plus 8 is 14. 8 plus 6 is 14, because you can flop. When you're adding, you flip the top two, right? That's the commutative property we talked about. Now we're adding in this direction, which means we can subtract in that direction. Subtract in that direction. So 14 minus 8 gives us 6, and 14 minus 6 gives us 8. And you will see that we're subtracting, we flip those bottom ones. All right, same thing for this guy. We've already got one of our fact families here. And remember, on subtraction, you can flip the last two. So our next fact family is this. 25 minus 15 gives us 10, because those guys can be flipped around. Remember, though, if we're subtracting in this direction, we can add in that direction. So if we add in that direction, we get 15 plus 10 is 25. And we get 10 plus 15 is 25. And those are your 4 facts for your fact family. Hopefully you found this helpful. Look forward to seeing you next time.